this short video, I'm going to show you how to calculate curve number raster for your watershed or your study area. Before getting started with this video, I'm going to talk about the data requirements and how you can follow along in this video with me. So as you can see right now, I have the boundary of the watershed right over here. I have a land use layer. This is the land use layer, and I have a soil. Let me turn off the land use, and this is the soil type that I have for my watershed. In order to download these data sets for your watershed, if you are within the United States, you can click on the link that I have provided for you in the description section of this video, and you'll be directed to different resources to be able to download all of these data sets. If you are outside of the United States, you need to refer to different websites in your country to download the data that allows you to calculate curve number. I'm going to give you an overview of what we need to be able to calculate curve number. The first tool that you need to be able to calculate curve number is ArcGIS Pro. I'm going to demonstrate in ArcGIS Pro how you're going to do that, so it's important to have access to ArcGIS Pro. Another toolbox that you need to have in ArcGIS Pro is called ArcHydro. ArcHydro is a collection of tools for water resources engineers to be able to calculate different geographic variables and perform different geographic analysis. My ArcGIS Pro is version 3.1, so I have downloaded and installed ArcHydro for ArcGIS Pro, and I will show you how it's going to look like once you install ArcHydro for ArcGIS Pro. If ArcHydro is installed, when you go under Analysis, and then click on Tools, and then click on Toolboxes, you will see ArcHydro Tools Pro already over here with many toolboxes that you can use. We are going to use a specific toolbox to calculate curve number raster in this example. We also need to access soil data. This website that I have put in the description section of the video for you allows you to download Surgo data within the United States for different states and HOC8 watersheds for different watersheds. So if you click on View, it will direct you to an ArcGIS online map, which allows you to download the soil data for the watershed that you want to. I have already done that, and I've already clipped the data to the extent of my study area. So let's wait for this website to load, and I'll show you how you can download the data. All right, so once the website is loaded, you can zoom in to the area that you want to. My area is in the state of Minnesota, so I'm gonna zoom in that state. My area was somewhere over here. So you click on the HOC8 watershed and then download the data set. Once the data set is downloaded, it's an ArcGIS Pro package. You're going to open that package, clip the area that you want to, and then import that area into your work directory in ArcGIS Pro. So this is how you will download soil data. Another data set that you will need is going to be land use and land cover. I've been using NLCD. Land use and land cover. This is an example. So when you go to this website, you can zoom in into the area that you want to download the land use and land cover, select the year of the land use and land cover that you want to, then you can select this download button over here and download land use and land cover for your area. I have already done that as well, and I'm going to go back to ArcGIS Pro and show you the data sets. All right, so that was a quick introduction of how you can download these different data sets. If you want a more complete explanation of how to download these data sets, I have a couple of videos that I'm going to link in the description section and also in my website, so you can have a better understanding of how to download soil data and land use data and so on and so forth. All right, so the other thing that you will need is going to be your lookup table. Eventually, we need to tell the model how to find different values of curve number for different land use types and for different soil types. Let me click on this and go to the attribute table just to show you how it looks like. So I've created this in Excel, LU value is a land use value. For NLCD, 11 represents open water. And for different hydro groups, A, B, C, D, you can see the value of curve number written over here. Again, I have used a simple Excel sheet, and I have created this table, and I've saved it as a CSV. I'm going to show you the Excel sheet right away. This is the Excel sheet that I've used to write the values of land use, soil hydro group, and curve number for every combination and every class. You can do the same thing and save it as a .csv and import this into your ArcGIS Pro. So let me show you how it looks like. It's right over here. And again, when I open it, it's exactly what I showed you in the Excel sheet. Perfect. Okay. You need one more thing that I forgot to import it over here. You need a value, or you need a raster for your DEM. Eventually, you're going to create a raster. That DEM is going to be your snapping raster. So I'm going to import that DEM and come back and show you how it looks like too. All right, as you can see, I've added a clipped 90-meter digital elevation model right over here to my watershed. I'm going to use this later. And the last thing that I want to mention before getting started with this video is that if you want to follow along with me, I have created a package that has all of this data over here in that package. You can click on the link in the description section of this video, go to my website and download that package and follow along with the exact data that I have over here right now. All right, with that explanation, I'm going to get started with the process of creating a curve number raster. I assume that you are familiar with SCS curve number method. In order to do hydrologic modeling, you need to have the depth of runoff. And SCS curve number method allows you to calculate that. In order to calculate that runoff, you need to have the value of curve number for your watershed. And that's how we are going to continue over here. And that's what we are going to find over here. Okay, so the first thing that I want to do is to show you the features of the soil. So when you select the soil, right-click on it and go to the attribute table, you will see that there are many columns over here. One column specifically that we are interested in is called hydro group. Let's see if I can find it. There we go, right over here. This hydro group column is the column that I am interested in because this allows me to have to assign a letter to each polygon in this soil layer. Just to show you the soil layer, let me turn these off. You can see if I zoom in, there are many polygons and each of them will have one hydro group associated with that. Okay, the first thing that I want to do, I want to visualize this. So right click on it, go to symbology, and then here we are going to have unique values. When you select unique values, automatically the field that is selected is the first field, the area of symbol, but we don't want that. We want hydro group. So find hydro group in this list over here, which is right over here. And then you can see the letters will show up over here. A over A, D, B, D, C, D, and D. Okay, and they will show up over here as well. Okay, so there are a couple of things that we need to change about this soil data. Number one, the first one is the symbol for all those polygons that do not have any values, the missing data. How do I know that? So right-click on your soil data, go to attribute table, and then again, find hydro group column right over here. Select it, right-click on the header, and click on statistics. It will give you this beautiful histogram that tells you that majority of your data has the hydro group of C, and then C/D, and there is some data that is missing. There are no values for that. The first thing that we want to do is to replace the missing data. But how do we do that? Because we don't know, actually, we haven't done any field work to know what is the hydro group of the missing data, right? We're going to do an approximation. We know that the majority of the basin, majority of the watershed has the hydro group of C. So we are going to replace all the missing data by hydro group of C. That would be a good approximation. All right, let me close this. And over here, I am going to click on select by attributes. Once you click on that, pop-up will show you this. Okay, and again, just to show you, I'm gonna go and find Hydro Group again and show you where it was. There we go. Hydro Group is right over here. Okay, so we are going to select the field, and the field is Hydro Group. When Hydro Group is equal to missing, the first one, select all the missing values. So apply. Now you can see that if I click on this tab, which is all the selected items, all the items that do not have any Hydro Groups are selected over here. So we want to make sure that all of these missing Hydro Groups are equal to C. Click on the header Hydro Group, click on Calculate Field, and then again another window will pop up. Let me show it to you. There we go, over here. And what I'm going to do is say that Hydro Group is equal to C, but make sure that you have the quotation over here because this is a letter. Okay, is equal to C, and then apply. You'll see in a second that all these selected items are right now have the value of C. Okay, now I'm going to go back. First of all, click on this so it clears all the selection. Nothing is selected. Go back to your table by clicking on Show All Records over here. Now, let's right-click on the soil data, and then on the attributes, we are already there. So if you're not there, click on Attribute Table. It will open it up. Right-click on Hydro Group, and then click on Statistics again. You can see that there is no missing data anymore because we replace all the missing data with Hydro Group C. The other thing that we need to change before doing the processes in ArcGIS and ArcHydro is to change this C/D, B/D, and A/D. What are these? So depending on the level of groundwater, the soil hydro group could be C or D. If it's well drained, the hydro group is going to be C. If it's not well drained, the hydro group is going to be D. Similarly for B/D and A/D. But when you are calculating curve number, you need to pick either C or D, either B or D, or either A or D. I'm going to go with the worst case scenario. I'm going to assume that the soil is not drained well, so all of these are going to be equal to D. So the same process that I did before, I am going to, in the attribute table, click Select by Attribute. This time, when hydro group is equal to, starting from A/D, click Apply, go to the selection. You can see that the hydro group A/D is selected. I'm going to right-click on it, Calculate Field. Instead of A/D, I want hydro group to be D, and then apply. You will see that in a second, all of the hydro groups are D. Click OK. All right, I'm going to change this again. Instead of A to D to B/D. Apply. B/D is selected. Right-click on it. Calculate the field, and then it's automatically D. Apply. It will change it to D. OK. And eventually, I'm going to go over C over D, and then apply. Right-click on hydro group header, calculate field, automatically it's D, apply, and you will see that it will be D. Perfect. Now, click OK over here, clear the selection by clicking on this button over here, and go back to your attribute table. All right, now let's do it again. I'm going to right-click on the hydro group header, and click on Statistics. Now you can see that I only have A, B, C, and D. And the frequency of C and D is higher than A or B. All right, this is the process of cleaning up your soil data. Now we have cleaned up soil data that only represents hydro groups A, C, and D. The next thing that I want to do is to convert my land use data, which is this one, to shapefiles. And how do we do that? All right, that's pretty easy. If you go under Analysis, Tools, I want to have Raster to Polygon. The first tool over here, I am going to click on it and then select the land use data. and then value should be selected over here. Have a name for it. I am going to say LU poly. I don't want my polygons to be simplified, and then click run. All right, the processing is complete. Now I can open the attribute table of this polygon and see the grid code is the value of land use. For example, 11, remember 11 was open water, and these number each represent one specific land use. Okay, I can turn the land use off over here and also the land use polygon off as well. I am gonna turn on the soil again. I need to calculate some variables for this soil as well, or add some columns to the soil. So let's open up the attribute table right over here. So what I'm going to do, I'm going to add a couple of columns at the end of my table, the attribute table over here. These columns are going to represent the percentage of the polygon that is represented by each letter, A, B, C, or D. Okay, how do I know that? Well, I know that, for example, let me select this polygon over here. This polygon is selected right over here. Let me zoom on it. So this polygon, it has 100% hydro group of, let's find the hydro group table right over here. There we go. So this polygon 100% is hydro group C. So we want to create 4 columns, %A, %B, %C, and %D at the end of this table. So I'm going to, first of all, clear the selection. There we go. And then I'm going to click on Add. Okay, so PctA is %A. I'm going to keep it long. That's okay. I'm going to click here to add another field. That would be PctB, and then add another one, PctC. Oh, I need to change that name, PctC. And then the last one would be PctD. All right, so once all of these are added, make sure that you save it by clicking on the Save button right over here. So you'll save that. Okay, now close this. And if you go at the end of the table, you can see that there are 4 columns added, and they do not have any values over here. Okay, now in order to populate these, it's pretty easy to do that. How do I do that? I'm going to again select by attribute, and I'm going to say if hydro group is equal to A, select all the cells, and it automatically selects all the cells that have hydro group of A. Okay, now what I want to do, I want to go all the way back. All the cells that have hydro group of A, the PctA will be 100% for them. So I'm going to right click on the header of PctA, calculate field, and then make sure that that is equal to 100, and then apply. You can see that it will be changed to 100%, and I can show it to you right over here, 100%. Next, I am going to close this and say select all the cells that have the hydro group of B, apply, perfect. And then I am going to right click on PctB and calculate fields and make sure that that value is 100 and apply. So these are all the cells that have 100% of hydro group B. Okay, notice that A, C, and D are 0. Okay, I'm going to do the same thing for C and D. All right, now it's time to clear the selection. We don't need it anymore. There we go. You can go back to the attribute table, and you can see that here the cells are completed depending on which one has a value. Sometimes A has a value of 100, sometimes B, C, and D. Okay, so this is all the processing that we need to do on the soil and the land use. The next step is going to be make these files, the land use and soil type polygons or shapefiles, one file. So we're going to join them together. In ArcGIS, in order to do that, we are going to use a tool called Union. So let me go back and search for Union. Union from the analysis tool. So click on that. It will ask you what is the first feature that you want to join. So we're going to select our soil data. Perfect. What is the second feature that you want to join to soil data? It's going to be my land use polygon, or land use shapefile. And what do I want to call it? I want to call it land use soil union. So LU underscore soil union. Perfect. That is, and I want all attribute to be joined. Okay, and then run that, and you will see that after a second, it's going to create another new shapefile for me. That shapefile is going to be a little bit larger than the area of my watershed. Why? Because my land use was larger than the area of the watershed. So let's wait for it. It's going to take a while because I had so many polygons that it needs to merge and make a union out of it. So this is the LU soil union. You can see that in addition to all polygons over here, it has created some polygons over here as well. Let's take a look at it. I am going to right click on this and then go to the attribute table. The first thing that you will see, there is some FID that is -1. These FIDs that are -1 are usually the FIDs that are outside of your watershed, and we want to get rid of those, okay? So how to get rid of that? You're going to select it by attribute, and then I'm going to say if FID is equal to -1, select all the cells. So I'm going to say apply, and it's going to select all those cells. So let's go to the selected ones, and you will see that all the -1s are selected over here. We want to remove all of that. And take a look at your map. All of these values that are selected are outside of your watershed. So we want to remove that. If you hover over this, it tells you that it's going to, this X removes all these fields. So I'm going to click on it, and it asks me if I'm sure I want to delete that. Yes. And after a couple of seconds, you will see that all of these values are removed, and you end up having LU soil union only for the values inside your watershed. Okay, I am going to go back to the selection over here. You can see now FIDs are 0, 1, all positive, all greater or equal to 0. And this is how it should be. Okay, now we need to modify, or in other words, we need to add another column to this LU soil union. And next, add a column to this table. Right now, you can see that the add is not activated. If that's the case for you, make sure that you go to Edit tab and save all the edits and click Yes. When you save all the edits, it will take a couple of seconds, and then the add button will show up. So click on the add. Okay, we are going to add another column, and this time I'm going to call this column land use. Land use. Okay, and I'm going to keep it as a long number. That's fine. And again, make sure that you save these edits actually over here. So you click on save right over here, and now you can close it. Okay, you can see that at the end of this table, there is a column called land use. I want this column to be equal to the column that says grid code. The grid code column, if I can find it, if you remember, that was the column that gives me the specific land use number for each polygon. Can I find it? Let's see. I'm going to scroll until, was it at the end? There we go, grid code. So each number represents one specific land use. So I want these numbers to be equal to the land use number over here. So what do? I'm going to select this column, right click on it, calculate field. I want my land use to be equal to grid code. So I'm going to find grid code right over here, and then double click on it. You can see that the grid code will pop up over here, and once I click apply, you can see that the grid code exactly will be copied into the land use column. All right, and that's done. It's right over here. Now that we have this, we are ready to create the raster. I'm going to check this off. I don't need it anymore. So I do have my lookup table. Again, this lookup table is included in the package that I have given to you, or you can just take a snapshot of this and create a lookup table if you're using NLCD data. If you're using another sort of data, the numbers and curve numbers would be different for you. Okay, so now that we have created this lookup table and have it over here, it's time to generate the CN raster, the curve number raster. So I'm going to search in the geoprocessing curve number generator, I think. There we go. So this is generate CN raster, and you can see it's from the ArcHydro Pro toolbox. Remember I showed you how to download ArcHydro Pro toolbox and install it? This is where it's going to be useful. So I'm going to click on that. It asks you for a digital elevation model. So I'm going to click on the digital elevation model that I have, the 90 meter one. If you want your curve number to be created for 30 meter, you need to add a digital elevation model that has a finer resolution. It asks for soil and land use polygon. This is the union layer that we created, LU soil union. And it asks for a lookup table, and this is the lookup table that I have over here, an LCD lookup table. Okay, so I think the problem is that this is saving it as a layer in a folder, but I want this to be inside the geodatabase. It should be in a geodatabase to be able to open it. So I'm going to open this geodatabase, and then in the geodatabase, I'm going to create a raster called CN raster. Okay, and now click save. Okay, CN raster. Now let's run and see. There we go. Okay, so this needs to be saved in a geodatabase. Over here, you can see the value of curve number that changes from 30 all the way to 100. I highly recommend to go to symbology and change the classes instead of 9 to, let's say, 5. And that will give you a better representation of your curve number, the areas that have high curve number and generate a lot of surface runoff, and also the areas that have lower curve number and do not generate a lot of surface runoff. So you can zoom in and investigate and analyze the areas as well. The other thing that is very useful to do is to right click on your curve number and go to create chart and create a histogram. So when you create a histogram, over here, you can click on the value and it will give you a histogram of different curve numbers. You can change the bin number to whatever number that you want to. For this watershed, it looks like the majority of the curve number, majority of the values are in between 86 to 89. So it has a higher value of curve number that has been created. Okay, so in this short tutorial, I showed you how to create curve number raster for your study area. Don't forget to check out the link in the description to be connected to my website and find all other resources that I have linked in the website that I have created for this specific tutorial.